Hello, today let's talk about cones and use an example from the 2001 AMC 12 question 8 or the AMC 10 question 17 to help learn about cones. So before we dive into the question, let's just talk about cones. So when I talk about cones, I usually would think of something like ice cream cones, which are delicious, or traffic cones, which are quite important. But in math, cones are just types of 3D objects in a specific shape. So in a cone, you have a base, which is a circle. And then you will have a height, which is the perpendicular distance from the vertex to the base, which is the height. And you have the radius of the circle because the base is a circle, as I have mentioned. Then you also have something called the slant height, which is basically this green line. So talking about cones is quite abstract, so let's look at a real one to get to know it better. Talking about a cone is quite abstract, so over here I have a real 3D one made of paper, so we can just look at it. So this is the slant height I was talking about. It's basically extended from the vertex, the tip, like the top of the cone, and the straight line to a base. It's different from the height because the height is, as I have mentioned, from the vertex and extend a perpendicular line to the middle of the base, which is like the shortest distance. But this is like on the surface of a cone. So that is a new term. And in the cone, we can also see that the base is a circle. So this is what a cone looks like. So I have cut open the cone and we can see that it's made from a sector of a larger circle. So the slant height is basically the radius of this sector, and then it's equal, all of them are equal, and then you have this arc length from the sector, and when we try to make a cone, it joins together to form the base. So here are the basic terminology of a cone. Let's go back to do the question. So welcome back, and now let's tackle the question together. So over here we have a sector of 252 degrees of a circle of a radius 10. So like the demonstration just now, we can just connect these two lines to form a cone. So as I have mentioned, the radius of the sector is equal to the slant height of the cone. So we can eliminate options B and D. Great. So nextly, we can calculate the circumference of the base because the circumference of the cone of a base is just equal to the arc length of the sector. So over here, the green length is just equal to 2 pi r times the angle theta over 360 degrees is equal to 2 pi times 10 times 252 divided by 360. So we have 14 pi. So now we know that the base of our cone has a length of 14 pi, and we want to now find the radius r. So 2 pi r is equal to 14 pi. After canceling out, we know that the radius is equal to 7. So the answer is C. In order to help further visualize the process, I've printed out the diagram of the cone. So we know that the radius is equal to 10 centimeters because it has been given to the question. So if like this length is 10, then this length is also 10, and like we can extend any point from the circle to the arc and it will be 10. So we can now fold the cone by connecting this edge and this edge. So we can have a cone that looks like this. Then we can see that the slant height is equal to 10 because we extended a line from the vertex and the base, and it is the shortest distance is equal to 10. Notice that the slant height is different from the height because the height is the perpendicular length from the tip of the cone to the center of the base, which would be something different from around here to here. So I can tape it up so the cone will be clearer. So this is how the cone would roughly look like. Thank you for learning with me, and I hope you learn more about cones. Thank you so much, and I look forward to seeing you in the next meeting. Bye!